So now that we understand number systems, one of the questions that often comes is how do computers represent numbers? That is, do numbers have to always be of a certain length? And if they are of a certain length, what do they represent? The most common number we represent on computers are integers. Integers are the most common numbers, and integers by definition, if you are on the number line, you have positive integers, so some maximum positive integer, 0 to maximum, and some negative on the negative number line. So we have numbers represented on the number line. So for the most part, we are happy to represent numbers as being unsigned. And that's what we did in the last description. When we say a number is unsigned, we are primarily focusing on numbers that range from 0 to some positive maximum. So unsigned numbers don't have a positive or negative sign. So an unsigned number. So let's take an example of an unsigned number. Here is an unsigned number, 1000 1101. And if I told you that this is an unsigned number which is in binary, we know what it represents. We know that it represents, again, I'm gonna, just to make the point, I say that this has a position of 0, 1, 2, 3, 4, 5, 6, and 7. And so one of the convenient things to do is to look at the numbers and just identify the coefficients that are non-zero, in this case the 1 coefficients. So the coefficients occur in positions 0, 1, 2, 3, 4, 5, 6, and 7. And the place values accordingly are 1, that's 2, this is 4 because that's 2 to the 2, this is 8, and this is 16, 32, 64, and 128. So I'm going to write this number as 1 plus 4 plus 8 plus 128, which is the number 141 in base 10. So what if we want to represent numbers that can have a sign? That it can be a positive number or a negative number. So let's take a look at what such a representation would look like. So the number 0, 1, 0, 0, 0, 1, 1, 0. Let's say this were a signed number in base 2. What we do when we're representing signed numbers is we assign a special meaning to the most significant bit. We call this the sign bit. And the significance is that a sign bit is either a 0 or a 1 to represent positive numbers or negative numbers. So here's a number, because it has a 0 here, has to be a positive number. So let's understand what this number represents. So this number then has the bit, this bit represents a place value of 2, this represents a place value of 4. So, and then we have 8, 16, 32, and 64. So this number then represents 64 plus 4 plus 2, which is 70 in base 10. Now, this is a number that is a positive number. So what if we have a signed number that is a negative number? A signed number that is negative, let's take a simple example of such a number. Here is a signed number that is negative. So 1, 0, 0, 0, 1, 1, 0, 1. And again, we notice that because this bit is a 1, this tells us that this number has to be a negative number. So what does it represent? Well, our place values are 1, that's a 2, that's 4, that's an 8, and this still has a place value which is 128. But now we notice that this number will actually represent 1 plus 4 plus 8 plus a minus 128, because that's a negative number. So this number represents a minus 115 in base 10. So in summary then, let's see if we can understand something about the ranges that these two number representations can capture. So let's look at how unsigned numbers go from, for example, if I have 8 bits that I have at 8 bits to represent, then I can go from 0, so from here all the way up to a 255. Now, if I have a signed number, again in 8 bits, because I have to represent both positive and negative numbers, I will only be able to represent 127 on the positive side, and I will represent minus 128 on the negative side. So the range is from minus 128 to plus 127. Here's a neat little trick that we use sometimes when we want to show numbers and show them in not in their full glory in binary, but to show them as in hex. So we could write this number again as a 8 followed by a D, because that's a 1101, which is 12 plus 1, which is 13. 13 stands for D. So I could represent this number as 0x8D. And that's simply a convenient way, so that when we look at numbers, it's sometimes simpler to represent them as binary, represent them as hex, or represent them as decimal. Okay.